Okay, I'm going to start making a series of videos on how to do the most recent Regents. We'll start from there. I'll cover a whole bunch of topics. You can feel free to request them. I'm doing videos because if you have any trouble figuring out any of this stuff, the versatility of this is that if I'm talking too fast or I'm working too fast, you can slow down the playback. YouTube will allow you to slow down the playback. I think it's under the little settings icon right below the video on the right. So you can slow it down. You can pause to see the work, read the question. You can work at your own pace, even if I'm working at mine, and you can replay it as many times as you want. So first off, I get all of my Regents at this website, jmap.org. You can click on Regents exams on the left-hand side, and then you can choose any of them. I'll show you what that looks like in the future if you have any trouble with it, but that's jmap.org. All right, so let's get started with this Regents. Algebra 2, Common Core, June 2017. Now, let's start with number 1. It says the graph of the function, p of x, so the p of x, they're saying the name of the function is p, that's just the name. He chose the letter p to represent the function, and the function p is a function of x. All functions are typically functions of the x variable. All right, so they're saying which equation could represent p of x. This is all about the roots of this function. The roots are these points right here. This is a root, this is a root, and this is a root. These are called roots, or sometimes they're called zeros. So roots are zeros, and these roots are -3, 2, and 3. What that means is, if I had a polynomial function equal to 0, and I was able to factor it, and I get these factors down equal to 0, and I t-charted it, just like we always do, essentially they're saying that my answers would be -3, 2, and 3. So if you remember, these all have x's in the beginning, and the question is, well, what goes in the bubble? For the first one, it would be +3. It's always the opposite of the sign. It's +3. The second one is going to be -2, and the third one is going to be -3. So if you're looking at this, you'll see that this doesn't particularly look like any of the answer choices. However, what they've done is they've taken these two, x +3 and x -3. These are what we call conjugates. Conjugates are what you can multiply together to get a difference of 2 squares. When you multiply these two together with the box method, you're going to get x squared minus 9. So we have x squared minus 9, x minus 2. That's answer choice number 1. All right, number 2. Okay, so for number 2, they're asking what is the solution? Solutions typically mean whatever the variable is, in this case x, they want you to get your answer to be x equals. Simple enough. The problem is that x is in here, it's got all this other junk around it that we're going to have to deal with first. So I'm going to rewrite this equation over on the side so I have a little bit of working space. The formula, the equation is 8 times 2 to the x plus 3 exponent is equal to 48. The first thing we have to do is the 8 is on the outside, we can divide that off. The 8 is attached by multiplication, so since it's multiplication, we'll use the opposite, which is division, to cancel it out. That's nice to cancel out on the left. I get 2 to the x plus 3 power is equal to 6, because 48 divided by 8 is 6 on the right. Now I'd love to get the x by itself. I got rid of those parentheses, that was nice. Got rid of the 8. But I can't get at the x because it's stuck in the exponent spot. Now here's the trick. Anytime something is stuck in the exponent spot, anytime we want to take it down, it needs to happen with a log. If you log this, you can take down the whole exponent. So what I'm going to get is I'm going to get x plus 3 times log of 2. And that's equal to log of 6. I'm going to divide the log of 2 off of both sides because it's attached with multiplication, so I can divide it off. And now I'm left with x plus 3 is equal to log of 6 over log of 2. I need to just minus 3 on both sides. And I've got my answer. X equals this. Log of 6 over log of 2 minus 3. If you look at the answer choices, you'll notice that log of 6 and log of 2 is not present, but we have something that looks very much like it. The answer is indeed number 1. So it's log of 6 over log of 2 minus 3. But they've just used ln. ln is nothing except for log base e. It means like the base of the log is that 2.718 number. So it's just a specific kind of log. They decided to use ln. There's no reason why they chose that over regular log. But so they're the same thing. So 1 is our answer. Number 3. Cheap and Fast Gas Station is conducting a customer satisfaction survey. Which method of collecting data would be most likely, or would most likely, lead to a biased sample? So it's not a good sample. We're talking about biasing the data, intentionally making it not fair. So I want to think about which would give me fair data, and I want to cross those out. So interviewing every 5th customer to come into the station. That seems pretty fair, so I'm thinking of crossing that one out. Interviewing customers chosen at random by a computer at the checkout. That's random, okay? Random is typically good. So that's true. That's a good one, so we want to cross that one out. We want biased. Interviewing customers who call an 800 number posted on the customer's receipts. This one's complicated. People who get decent service, people who get good service, they don't typically call an 800 number posted on a receipt. They're not going to call. The only people that would call are people who had negative experiences and wanted to complain about something. So this would lead to a biased sample. We would only get input from the people who called, which are typically people who have complaints. So we would never hear from the good experiences. We never hear from good customers, only bad ones. Number 4. The expression 6xi cubed times negative 4xi plus 5 is equivalent to. This is relatively simple. They just want us to distribute this onto here. It's a bit of a complicated distribution, so if you were uncomfortable with it, then here's how it works. When I distribute, I'm just multiplying. So essentially my first multiplication is this term times this term. When I multiply, I'm only multiplying the like terms. So I'm multiplying 6 times negative 4. That's going to get me negative 24. Now x times x is going to give me x squared. I cubed times I is going to get me an I to the 4th. I'm not done. I still need to multiply the other term. Multiply onto there. So 6xi cubed times 5. Well, the only things that are like are the 5 and the 6. So this is going to be plus 30x I cubed. And none of these are the answer because I to the 4th and I cubed are not simplified yet. We can simplify those either by using the wheel. I'll put this on here just to remind you. Or you could use a calculator. You can just type in I to the 4th in the calculator and it'll tell you what it's equal to. Just the small powers of I, it'll simplify it for you just straight out. But if you wanted to know, I to the first power is I. I squared to the second power, that's going to be negative 1. I to the third power is going to be negative I. I to the 4th power is going to be 1. So I can essentially substitute these. I to the 4th becomes a 1. Multiplying something by 1 doesn't change anything. That's nice. I cubed is going to become negative I. I'm going to multiply these into their respective terms and then just rewrite it, and you'll be able to see which the answer is. Negative 24x squared times 1 is, oh wait, nothing changes. Negative 24x squared. Now, positive 30x times negative I is going to give me negative 30xi. Make sure you look for the answer choice where they're both negative. And it's going to be choice number 2. Negative 24x squared minus 30xi. Question number 5. If f of x, the function they're calling f, is equal to 3 times the absolute value of x minus 1, and g of x, the function g, is equal to 0.03 x cubed minus x plus 1. They want to know an approximate solution for the equation f of x equals g of x. So they're saying f of x equals g of x. So if I rewrite this, I'm going to get 3 absolute value of x minus 1 is equal to 0.03 x cubed minus x plus 1. Now, if you wanted to try to solve this straight up, you're going to have a very hard time. We've got two things in here making this very complicated. The absolute value of x and the x cubed. We don't have very much experience in solving directly either one, so we're not going to want to do that. One thing that we can do, though, is we can graph both equations and we can look for their intersection point. You need to remember that a solution to two or more equations is an intersection point. So I'm going to take it to the calculator now. Solution to two or more equations is an intersection point. So I'm going to want to graph both of these. So we're going to go to our calculator. Go to y equals. I already have some junk in here, so let me delete that. We're going to put in the two equations. 3 times the absolute value. Now, absolute value in your calculator is going to be found over here on the left-hand side. It's under the math button. You can hit math, go over to number, and it's right on top, ABS, that's absolute value. So we get the absolute value of x, close the parentheses, minus 1. Make sure you're using this minus, the one over here, and not this one down here. This is a negative sign at the bottom. It's the one on the right, the blue one, that's the minus. Now the next one is, second equation is 0.03 x to the third power minus x plus 1. I'm not sure what my graph is going to look like. I don't know how big or how small these functions are, so I don't want to just hit graph. What I want to do is I want to go to zoom, which is on the top, and hit zoom. And I'm going to scroll down to 0, which is zoom fit. Zoom fit. It tries to fit your functions in the window when it graphs it. So I'm going to hit zoom fit, enter. Give it a second to process and graph the function. That's my first one. And that's my second function. It's great. I can see the intersection point. It's right over here. The problem is I don't want to have to guess where that is on the graph. The markings are not really easy. So what I'm going to do instead is I'm going to go into this menu here under trace. It's above it is this calc. I'm going to hit second trace to go to the calculate menu. Second trace. And you'll see that I can calculate a value, a 0, a minimum, a maximum, or an intersect. I'm going to calculate the intersect. So I hit enter here. Now you'll see at the bottom it asks first curve with a question mark. You can see that I have a point here. Yeah, that's on my first line. So yes, that is my first curve. I'm going to hit enter. Second curve. Well, you can see this little dot along the bottom here. Yes, this is my second curve. So I can hit enter to confirm. And then I'm not sure why, but it asks you, like, are you sure you want me to guess? And we say enter for yes. We do want you to guess. Where's the intersection point? Now if you look here, the intersection point appears to be where x is equal to like 11.3 and where y is equal to 32.9. So we're looking at like 11 and 32. So let's go back to the sheet and we can see which one our answer is. Okay, so when we go in here, I know it's not this, and I know it's not this. The question is it 2 or is it 4? Do I want the x value, or do I want the x value and the y value? Because both of these are correct technically, but there's only one that they want as the answer. If you look at the equations that we drew out when we set them equal to each other, there are no y's in here. If we solved it, we would only be solving for the x values. So all we want is the x, and their answer is going to be 2. One more question before I cut it into a second video. I don't want to overwhelm and put too many questions in a single video, make you feel obligated to sit here for an hour and a half while I finish the whole Regents. So let's do this one last one. Given the parent function, p of x, so it's just the name of the function, that's equal to cosine of x. Which phrase best describes the transformation used to obtain the graph of g of x, which is cosine of x plus a minus b? Essentially what they're saying is like, hey, we have two functions here. What changes occurred from the first one to the second one? What changes did we make? They give us that a and b are positive constants, just so that plus and minuses mean what they look like they mean. So if I'm looking here, you need to remember transformations on the inside are left and right, and they're also opposite. So on the inside, they're opposite. So if you're thinking left and right, you would think that plus a, you would normally think that it would go to the right. But plus a goes to the left a. So it's going to the left a units, whatever a is, 5, 100, it doesn't matter. It's going to the left a units. Over here on the right, these are the easy ones, minus b. These are up and down shifts, or translations, if you want to speak in geometry terms, up and down. These are regular, so when we do minus b, this is going down b units. So I just want an answer choice where we're going left a and down b, which is number 4 here. Okay, you can look for the next video in the series starting at question number 7.